Welcome all. In this video we will study about binary operations. Our learning objectives in this video are: what is binary operation, how to represent binary operation, and properties of binary operation. So let us start. Now what is a binary? Binary means 2. Here we can see, for example, addition of two numbers. Here we can add two numbers and we get the result as a single number. So addition, we can say, is a binary operation which we can apply on two numbers. In the same way, subtraction, it is also a binary operation. We can subtract two numbers and get result as a single number. So it is also a binary operation. Then again, division, we can apply division on two numbers and get the result as a single number. And then multiplication, we can multiply two numbers and get the result as a single number. So all these operations, we can say these are binary operations. Now consider the definition. What the definition says: a binary operation star on a set A is a function star from the set A cross A to A. Here A cross A is the Cartesian product of the set A to itself, and its elements will be of the form ordered pair, that is bracket A comma B, where both A and B belongs to A. And the output will be a single number, that will be A star B, after applying the operation which we are considering. So we can say we denote binary operation by, if we apply binary operation on two numbers A and B, we denote it by star bracket A comma B or bracket A star B, where both the elements A and B belongs to the set A under consideration. For example, we can consider addition on integers. So here the set A will be the set of integers, and we can see that if we add two integers, what we get? We get an integer again. So we can say that addition on integers is a binary operation. So here we can see that it is important that what is the output, that should be this element of the set A. This is the important thing in binary operation. Now consider this table. Here we are given 4 operations: addition, subtraction, multiplication and division. And we are given 3 sets: set of real numbers, set of natural numbers and set of integers. So here we will check whether these operations are binary operations on the given sets or not. So let us start with the set of real numbers and consider the operation addition. So we consider two elements, 2 and 5. We can see 2 and 5 both are real numbers. If we add these two elements, 2 and 5, what we get? We get the result as 7. And we can see 7 is also a real numbers. So in general, we can say if we add two real numbers, we always get a real number. So this addition is a binary operation on set of real numbers. Now consider subtraction. Again we subtract these elements 2 and 5. 2 minus 5 is equal to minus 3, which is again a real number. So we can say here also subtraction is a binary operation on set of real numbers, because if we subtract any two real numbers, we always get the result as a real number. So subtraction is also a binary operation on set of real numbers. Now consider multiplication. Again we consider two elements, 2 and 5. We can say we multiply 2 and 5, we get the result 10, which is also a real number. So in general we can say if we multiply two real numbers, again we get a real number. So we can say multiplication is also a binary operation on set of real numbers. Now consider division. Now again, if we divide 2 by 5, what we get? A real number. But if we divide 2 by 0, we can see 2 and 0 both are real numbers, but 2 by 0 is not defined. It is infinite. So it does not belong to real numbers. So we can say division is not a binary operation on set of real numbers. Now consider a set of natural numbers. Again, consider the operation addition. Now we will check whether it is a binary operation on natural numbers or not. For that we take again two elements, 2 and 5. Both are natural numbers, and if we add 2 and 5, what we get? 7, which is again a natural number. And in general we can say that if we add two natural numbers, the result is again a natural number. So the operation addition is a binary operation on set of natural numbers. Now consider the operation subtraction. Again we subtract 5 from 2, that is 2 minus 5. If we say 2 minus 5, that is equal to minus 3. But minus 3 is not a natural number. So we can say if we subtract two natural numbers, it is not necessary that we get a natural number. So this subtraction is not a binary operation on set of natural numbers. Now consider multiplication. Again we multiply 2 into 5. That will be 10, which is again a natural number. And in general, if we multiply two natural numbers, again we get a natural number. So multiplication is a binary operation on set of natural numbers. Now for division, we see 2 divided by 5. That is not a natural number. So we can say if we divide two natural numbers, it is not necessary that the result is again a natural number. So division is not a binary operation on natural numbers. In the same way, we can check for set of integers. If we add two integers, for example 2 and 5, we again get an integer 7. And in general, if we add two integers, we get an integer. So addition is a binary operation on set of integers. Again, subtraction. If we subtract two integers, for example 2 minus 5, again we get an integer, that is minus 3. And in general, if we subtract two integers, we get the result as an integer. So we can say subtraction is binary operation on set of integers. Now consider multiplication. The same way we can check 2 multiplied by 5, that gives us 10, which is an integer. So in general, if we multiply two integers, we get the result as an integer. So multiplication is again a binary operation on the set of integers. Now comes the division. Now division, if we divide 2 by 5, what we get is not an integer. So we can say that it is not necessary that if we divide two integers, we always get an integer. It is not necessary. So division is not a binary operation on the set of integers. So it is all about binary operation. Now consider the example. It will be more clear with these examples. Determine whether or not each of the definition of star given below gives a binary operation. Here we have to check that star is a binary operation or not. In the first example, star is defined on set of real numbers and defined by a star b equal to ab square. If we apply star on two numbers, what we get is a into b square. So let us check whether it is a binary operation or not. Now here star is defined from r cross r to r, where r is set of real numbers. Now again consider two elements minus 3 and 5, which are both real numbers. if we apply this operation star on minus 3 and 5, what we get? Put a equal to minus 3 and b equal to 5. So we will get minus 3 into 5 square, that is minus 3 into 25, which is equal to minus 75. Now minus 75 is again a real number. So in general we can say if we apply this operation star on any two real numbers, again we get a real number. So this implies this star is a binary operation on set of real numbers. Second example says it is defined, this binary operation is defined on set of positive integers defined star by a star b equal to mod a minus b. Here the operation on two elements a and b is defined as mod a minus b. So let us check whether it is a binary operation or not. Consider two elements 1 and 4. Both are positive integers. Now if we apply this operation star on 1 and 4, what we get is mod 1 minus 4. That is equal to mod minus 3. That is equal to 3. Now 3 is again a positive integer. So we can say in general this operation a star b, which is equal to mod a minus b, it always generates a positive integer. So this operation is defined on set of positive integer and it is a binary operation on set of positive integers. Now consider the properties of binary operations. Now here star is a binary operation. Let it be defined on a set A, that is it is from A cross A to A. Cartesian product A cross A to A. Now first property is commutative property. What is this property? This property says if A and B are two elements of the set A, then A star B is equal to B star A. That is, if we change the order of the elements, the result does not suffer. The result will be same whether we write A first or B first. Now let us see the examples. First see the operation addition. If we add two numbers, for example minus 2 and 5. If we add minus 2 and 5, that is minus 2 plus 5, the result is 3. If we change the order, that is if we place 5 in first place and minus 2 in second, then again we get the result 3. So order doesn't matter. So this operation addition, we can say it is a commutative operation. Now consider multiplication. If we multiply two numbers, for example, if we multiply 2 and 3, 2 into 3 is 6. Again, if we change the order, that is 3 into 2, that is again gives us 6. So the result doesn't suffer. So this operation multiplication, we can say it is also commutative. Now consider subtraction. Here the order matters. If we subtract 3 from 5, we get the result 2. But if we change the order, that is we subtract 5 from 3, we get the result minus 2. Here the results are different. So we can say subtraction is not commutative. So what is the commutative property? The commutative property means that if we change the order of the elements, the result should be same. Now consider the another property, that is associativity. Now associativity says if there are let us consider three elements A, B, C which are in set A, then associativity property says that A star B within bracket star C equal to A star bracket B star C. That means that if we apply binary operation on AB first and then we apply binary operation on result of A star B and C, we get the same result as if we apply the operation on BC, B and C, and then we apply the operation on A and result of B and C. So let us consider the example. that will be more clear. Now consider the case of addition. Let us consider three elements minus 2, 3 and 5. If we add minus 2 and 3 first, what we get? 1, and add 5 to them, that is 6. Now if we add 3 and 5 first, we will get 8, and then add minus 2 to that, we will again get 6. So here we get the same result. If we apply the operation on AB first, then C, or if we apply the operation on BC and then A and the result of B and C. So here we can say addition is associative. Now consider subtraction. Again consider three elements 2, 3 and 5. Now here we can see if we subtract 2 from 3 first, we will get minus 1, and then subtracting 5 we will get minus 6. Now again if we subtract 3 and 5, what we get is minus 2, and 2 minus minus 2 is equal to 4. So here the result on both sides is not equal, so we can say subtraction is not associative. Now consider multiplication. Again consider three elements 2, 3 and 5. First multiply 2 and 3. What we get is 6. Then we multiply it by 5. We get 30. Now multiply 3 and 5. What we get? 15. Now 2 into 15 is again 30. So here also the associative property holds, and we can say multiplication is associative. So this is all about properties of binary operations. Now consider identity. What is identity of a binary operation? How do we define an identity? Let us consider a binary operation from set A cross A to A. Now how do we define identity? Identity is an element E which belongs to set A, where A star E is equal to A is equal to E star A for all A in set A. Now what does it mean? It means identity is an element which belongs to the set A such that if we apply the operation between A and E, that is A star E, we get the element A. And also it is commutative, that is if we apply the operation between E and A, we change the order, then again we get the element A. Now consider the example. Now suppose addition. Consider addition from set of real numbers R cross R to R. Now here consider elements 0 and A. Both are real numbers, and if we add 0 to any real number, what we get is the same real number. That is A plus 0 is always equal to A, and that is equal to 0 plus A. So if we change the order, the result does not suffer, and A plus 0 gives us A. So we can say 0 is identity for addition, binary operation addition on set of real numbers. Again consider the operation multiplication on set of real numbers. Here we can see 1 is a real number, and consider any other element A which belongs to real number. If we multiply A and 1, what we get is A. And if we change the order, that is if we multiply 1 and A, again we get A. So here we can say 1 is identity for the binary operation multiplication on the set of real numbers. Now next comes inverse of a binary operation. Again consider a binary operation from set A cross A to A. Now let A be the identity for star. Then how do we define inverse? B will be an inverse of A with respect to star if A star B equal to E equal to B star A for all AB belonging to the set A. What does it mean? B will be an inverse of A if we apply the binary operation on A and B, that is A star B, And if we get the result as identity of the binary operation, and if we change the order, that is, if we apply B star A, again we get the identity element, then we say that B is inverse of A with respect to star. Consider the example. Now consider addition as binary operation on set of real numbers. Now consider an element A. If we add minus A to A, what we get is 0, and 0 is the identity, additive identity of set of real numbers. Again, if we change the order, that is if we add minus A and A, that is minus A plus A, again we get 0, which is the identity for addition on set of real numbers. So what we conclude? We conclude that minus A is inverse for binary operation addition on set of real numbers. Again, consider the binary operation multiplication. Now, what we see, if we have a real number, say A, and if we multiply it with its reciprocal, that is 1 by A, what we get is 1, and 1 is the identity for the binary operation multiplication. So we can say 1 by A is inverse for A in case of binary operation multiplication on the set of real numbers. So this is all about binary operations. I hope this video is useful for all of you. Thank you. And if you like my video, please press the like button and subscribe my channel for more videos.